Okay, so, for 1.3, we're doing rates of change in linear and quadratic, okay? So it asks, the average rate of change, or it says, sorry, is equal to the slope of a secant line. Anybody know what that is? Okay. A secant line is kind of what we did yesterday. Do you know on yesterday when we did, like we found a point and we drew a line through it to represent the slope?
Yeah.
Okay, same type of thing. With this, it's a secant line. Let's pretend like this is point A and this is B. Okay, we have A and B. And those are my 2 points. And then if I draw a line between them. So that is a secant line. It's just simply called, or it's just simply a line between 2 points on a graph. Okay? Okay, so if I have A and B, the y value of this is going to be f of A, and the y value of this is going to be f of B. Okay, so you know, like way back when people first started developing mathematics, like Pythagoras, okay? He probably did the Pythagorean theorem hundreds of times, right? And then he decided, oh, this works every single time, then I'm going to take out the numbers and I'm going to put a squared plus b squared equals c squared, right? Okay, so that's kind of what they want you to do here, is to find the average rate of change with these 2 points. What would you do?
Find the slope.
Yeah, so how would I do it? Can you, like, what would I put first?
B minus f of A over
Yes, Miriam. Was that you?
Yeah.
Okay, f of b minus f of a over b minus a. Jolly Rancher?
Just B.
Ooh, nice. Okay,
I like B.
so this is our slope, okay?
Just to clarify.
This is our slope, and I know it looks kind of ugly, doesn't it? But it really is just the y2 minus y1 over x2 minus x1, but it's just written in a different form, okay? Try not to over analyze it, okay? All right, so if I asked you to find the slope of this first one, how would you do it?
Just 2/3.
2/3.
Just 2/3. Why, Kenrick?
Because it's 2/3. X almost.
Perfect.
M value.
You looked right here. Fantastic. So the slope is 2/3. What's another way?
It goes up 2 over 3.
Ooh, nice. You could pick 2 points. Up 2 over 3. Okay, I could do rise over run. Or I could do points 0, 0, and 3, comma 2, and then I would do 2 minus 0 over 3 minus 0, which is 2/3. This is one of the things like I love about math, is there are so many different ways to do things. So please know, like if you can do it one way, my way and your way might be totally different, but as long as they're both right, you know what I mean? Like you get the correct answer at the end, that's fantastic. Okay? So what about the slope of the next one? -2. Fantastic. Who is that, Erilyn? Oh, that was a bad throw, I'm sorry. Okay, here to here. So 1, 1, 0, 3. So if I do 3 minus 1, 0 minus 1, I get 2 over 1, which is negative. This is negative, yeah, sorry. Easy, right? I feel like we've been doing this since 5th grade, okay? So what's the next one?
0.
0. Whoa, lots of you. Who do I give the jolly to?
Me. I literally said I said it first.
I said it.
I look at you was gross.
I said it
I
myself.
said it beside.
-2,
Yeah, bro.
-3. 0, -3, so -3 minus -3 is 0.
Or you could look at it.
Or you could look at it. Okay, so. Okay. Bryce, I heard Capri, and Isabel?
Oh, it's a good one. We know where to go.
Well,
Did you too?
yeah,
It's you, Jacob.
yeah.
I heard him say it.
Oh, sorry, Case. Okay, so the average rate of change for a linear function is, what do you think? Constant. Fantastic. You are on it today, Isabel. Was that you?
Nope, Miriam.
Oh, Miriam, sorry.
It was me.
Nice. You do. It just comes like the voice, and I just hear, sorry. Regardless of the input value interval length. So it doesn't matter how far apart I go. So if I went up 2/3, if I went up 4/6, that's a different interval length, but the slope is still going to be 2/3 in that instance, okay? So it doesn't matter. Linear doesn't matter. Now, this is where it gets a little bit tricky. Okay, they throw in something new. So they're reminding you of what you've learned for many years, okay? And now they want the rate of change of the average rate of change. Okay? So here's my easiest way to explain it. Okay, here's the easiest way I can see it. This is just how I see it. So, do you remember in Algebra 2, we used to do little tables like this? Okay? If I put in 0 to that equation, I would get 0. If I put in 1, I would get 2/3. If I put in 2, I would get 4/3. And if I put in 3, I would get 2. You with me so far?
Yeah.
Okay. So, and then do you remember we would find the first difference? Okay? When I am going up by 1, okay, and I find this difference, okay, that's 2/3, and then I find this difference, that's 2/3, and I find this difference, that's 2/3. If these are all going up by 1, that essentially is what? What's that equal to? What does that equal to? The slope. Who said that? Oh, that was bad. I'm sorry. Okay, this is the slope, essentially. Yes, it's the first difference, but when you divide by 1, it's also going to be your slope. Okay, do you guys get that? Does that make sense? So that first difference is your slope. Okay? So now, the rate of change of the average, this is the average rate of change. So what's the difference here? 0. What's the difference here? 0. Okay? So this is just proving the theorem that we're going to talk about down here. The rate of change of the average rates of change of a linear function is, it's kind of the same thing here. If all of those were -2, that's going to be 0, right? And then if this last one, like this was all 0, 0, 0, then my second difference is 0. So the rate of change of the average rate of change of a linear function is always 0. The second difference, you could say, okay? But really, it's the average of the slopes, okay? Because you're dividing by 1 again. You're just dividing by, it's going by an even interval, okay? I know. All right, now we're on to quadratic, okay? So, linear functions, it's not an average. It is, that was the slope, right? 2/3 was the slope. There was no average about it, okay? Why they say average, like up here, they say find the average rate of change. Because watch what happens. If I go on a parabola, if I go from 1 to 2, if I go from 1 to 2, and I draw a line, does that replicate the parabola? No. I mean, it's close, isn't it? It's super close. Okay? But the parabola is a curve, and rates of change are straight lines. Okay? So that's why they're saying this word average is because we are averaging that curve and getting us like it's pretty accurate type of thing. Does that make sense? Where the word average comes from? So I'm going to find the slope on this little chunk of my parabola. Okay, that's all that is. So I'm going to have 1, -1, and 2, 0. So 0 minus -1 over 2 minus 1 is 1 over 1, which is 1. So on that interval of that parabola, the slope is 1. Does that make sense? Okay. So then, for the next one, they want us to go to a different part of the parabola, and they want us to go from 2 to 3. So now I'm on this part, and I'm gonna figure out what's the average slope of just this pink section. Okay. So if I have 2, 0, then I have 3, 3. So 3 minus 0 over 3 minus 2 is 3 over 1, which is 3.
Do you even like do straight work for that or no?
I mean, you can do rise over run.
Okay.
That could totally be enough work too. I'm just showing it out because I have to show you what my thought process is so that you understand it. Yeah. So 3 to 4. So 3 is here. 4 is here. So 3, 3, and then 4, 8. So 8 minus 3 over 4 minus 3 is, so do you notice a pattern?
Mm-hmm.
Okay, 1, 3, 5, what's happening?
It's
Going up by 2. Okay, so these are slopes. These are averages of slopes at these different parts of that parabola. So the first part, if I started here at 0, the first part would be a slope of 1. Like you're just kind of going up gradually. Pretend you're like in your car going up a hill. That's a slope of 1. Then it goes to a slope of 3, which is like super steep. And then it goes to a slope of 5. Okay? And then what do you think is going to happen? Yeah, it just keeps getting steeper and steeper, doesn't it?
Yeah.
Okay?
It is 7, right?
Yes. So here's the equation. Why? Because now they don't give us graphs. They want us just to do it from this interval. So x squared y equals x squared minus 2x. Oh, I forgot to say we're not using calculators. Have you noticed that?
Well, yeah.
Yeah, we don't need a calculator. So we're going to try and do 1.3 without a calculator. So if I fill in 4, well, I did 4 over here. So 4 was 8, because it's the same exact equation for all of these 5 problems. What's 5? 5 squared is 25, minus 10 is 15. Perfect.
Yeah.
So 15, Micah, you want a Jolly Rancher?
Sure. Wait, how do we get that minus 2x again?
That is, I just copied it. They told it to us at the top.
Oh, okay.
We just didn't use it because we had the graphs. We didn't really need it, and now we need it. Okay, so 15 minus 8 over 5 minus 4 is 7 over 1, which is 7. And then we can do 6. So 5 is with 15. What's 6? 6 squared is 36 minus 12, 24. 24 minus 15 over 6 minus 5. This, okay, so, nice thing about a lot of these, when you're forced to do it in your head, is it kind of like self-corrects. Like if you don't get the next number in the pattern, you're like, oh, I did something wrong. You know, you have to go back and check your work. Okay, so, the average rate of change, so if I took this off and just said slope, for a quadratic function does not stay the same, does it? So as you climb up that hill, it's not going to be the same. And as the other side's going to all be negative, right? So they're not the same. For consecutive equal length input intervals though, the rate of change of the average rate of change of a quadratic function is constant. Now let me show you. That's that +2 that you guys were saying.
The second difference.
Yes, fantastic. Smarties. Okay, so if I just showed it out like this, okay, watch. So 1 was -1, 2 was 0, 3 is 3, 4 is 8, 5 is 15, and 6 is 24. Uh-oh. Child is calling me. Okay, so
Group
what's,
FaceTime.
huh,
Group FaceTime.
with the whole class?
Yeah.
Hey Jackson, what do you want?
Yeah.
No, I'm not doing that. -1 to 0, what's that?
It's
1.
You messed me up.
I know.
What?
0 to 3, 3. 3 to 8, 5. 8 to 15, 7. 15 to 24, 9. Okay? So, like we were just saying, that's our
First.
slope, first difference. These numbers are the slope. This is our average slope for the quadratic function. It's not the same, but it's increasing, isn't it? So what were we going on? We were going on the increasing side of the parabola, weren't we? Okay? And then if I do the second difference, like Miriam was saying, that's your, so it's the rate of change. So this was the slope. This is the rate of change. If you just write ROC, that's perfectly fine. Of the average rate of change. I know, it gets kind of wordy. That gets really wordy, and I'm like, is it the rate of change, or is it the average rate of change, or is it the rate of change of the average of rate of change? It's like, okay? So for this problem, the constant was 2. Will it always be 2?
No.
No, it will change because quadratics all change. You get like really steep ones, really wide ones, all different. Okay, so can you find, for 12 and 13, can you find the constant?
Right?
So find, yeah,
Can I go on the toilet?
yes. Just make a pass. That's what they say in Europe,
What?
the toilet.
Oh.
It makes more sense than bathroom, because bathroom means you're taking a bath,
The restroom?
don't you think? Restroom, are you taking a rest?
Kinda.
You stand up.
I'm taking a
I
rest
mean,
in class.
Taking a rest, yeah. Isn't it funny how we change words and we're just like, I feel like you're made up sometimes.
Yeah, I use the powder room.
Powder room, yeah, because I gotta put powder on my face.
Yeah, to powder my nose.
Somebody, you know when you fill out that pass and it gives you the icon? Did you ever seen the girls one?
No.
Last year it was pink. And it had like, it looked like somebody was pointing at a mirror, like, cause we always look at the mirror. And the boys, what's the boy icon? I don't even know.
Well, that's just toilet paper.
Toilet paper, which makes sense. Why wouldn't ours be toilet paper? Because we only go to the bathroom to powder our nose? No. You know what I mean? Somebody's like, that's so sexist. I know. We do go in groups because we like to talk to each other. Oh, seriously?
That's not usually the
That's my sleeping.
I just pee to pee. Somebody's gonna watch this video and be like, why are they talking about peeing?
Oh, you're filming? Oh.
Yeah.
Oh, thanks
yeah.
for the heads up.
Ah, it's okay, who cares?
Oh, I think I figured it out.
I know. Okay, so, what did you guys start at? Did you make a table?
I did one, start at 1.
Start at 1. It does not matter where you start, you're still gonna be able to find it. If you start with the vertex, you know, if you did like -b over 2a and you did the vertex, the numbers are gonna repeat and it makes your job easier when you don't have a calculator, okay? So this is just 0 over 2 times -2, so that's 0. So I'm gonna have 0 in the middle and I'm gonna do 1 on each end. So negative 2 squared is 4, times negative 2 is negative 8, plus 10 is 2. Negative 1 squared is 1, times negative 2 is negative 2, plus 10 is 8, 0 plus 10 is 10, and then these repeat. 1 squared times negative 2 is 8, and 2.
I'm gonna get lost.
So,
Wait.
2, I know, it was so funny because all my hours are like, I need to go back to learning how to do addition and subtraction in my head.
Please.
Because you get kind of,
I've never.
I think I got the slope wrong.
you get reliant on your calculator or your phone, because you guys have your phone, so you can just take it out, right? So this goes up 6, up 2, down 6. So then this is going down 4, down 4, down 4. So, look at the difference, okay? So this was a constant of 2. This is a constant of negative 4. And my slope is going down. So what does that mean? That kind of tells you.
Is it?
Ooh, good one. Okay, ooh, yes. Concave down, upside down, yes. Fantastic. Okay. This one, what'd you guys start at? Negative b over 2a.
Wait, Miss Liley.
Yeah,
The y value for x.
yep.
If it's negative 2 times 1, so that's negative 2, isn't it negative 2 squared 4? So wouldn't it be 14?
No, so you have to do order of operations and you have to do the squared first.
You have to do a squared first?
Yep,
Why?
because of PEMDAS.
I thought
Please excuse my dear Aunt Sally, so you have to do the E and then the M.
Oh, so, okay.
So this part has to go first,
Okay, that makes more sense now.
yeah. So I am not doing 1/3 because that's ugly, right? So I'm just gonna go 0, 1, 2, 3. Still get the same answer, guys, it does not matter, you do not have to do fractions. 0 and 0 is 0, put 1 in, 1 squared times 3 is 3, minus 2 is 1. 2 squared is 4, times 3 is 12. 12 minus 4 is 8. 3 squared is 9, times 3 is 27, minus 6 is 21. So those are my slopes. So a slope of 0, then it's going to go to a slope of 1, a slope of 8, and a slope of 21. So this is going up 1, up 7, up 13. So then 6 and 6. So my slope is going up. So that probably means it's concave up. Nice. Okay, one last problem and then we're done. The values of the function are given at selected x intervals in the table. Now be careful, because on AP Classroom or on other things, they might give you, like the SAT that a lot of you guys juniors are taking next month in October, the PSAT. They might give you numbers that aren't in order. They might give you just random numbers, just trying to trick you, okay? So this is important to notice. You can only do these like where you find the first difference, second difference, if the numbers are in order, okay?
If they're not, what are we doing?
So then you can try and figure it out and then like fill in the
Concave down.
blanks. If you fill in the blank, that's what I would do. Like I would make a blank table and I'd leave the spots blank. Yeah, and then try and fill them in and then see like if your pattern is continuing. Okay, so determine if it's concave up or concave down.
Sit down.
Yeah, definitely down.
So there's a couple different ways you can do this. If you wanted to, you could over on the side,
That's what I would do.
you did this, yeah. You could just sketch a little graph. Sometimes it works, sometimes it doesn't work though, okay? And if you notice, if you did this, 2, 0, down 2, down 4. So if I go over 15, up 18, I'm just guessing, over 16, up 20, over 17, 20, 18 goes down, and then 14. You can easily
Is
see,
that all you have to do to show your work?
yep.
I bet.
Okay, but now you have to, okay, you really don't have to show any work. It's just asking for, is it concave up or down?
Do you have to do that whole thing?
You have to give a justification, okay? You can't just say one or the other, you have to say why, okay? It's kind of like if your boss at work gave you a problem and you figured it out, and you just said, oh, I just figured it out. Like, they want to know how you figured it out so they can replicate it, right? Isn't that the whole purpose? Okay? So the actual wording, what do you think the actual wording would be? What is this?
G of X, or G, oh,
What are these numbers?
the slope.
The slope or the rate of change. Fantastic. So those are my rate of change. So we're saying what? We're saying g of x, fantastic, is what?
Under now.
Concave down, fantastic, concave down, because the rate of change is, no, decreasing. Because right here it's not negative, right here it's 2, right here it's 0, those aren't negative. So do you remember when we started this whole concave up and concave down, I told you it has to say rate of change? Okay, that's this, like, they're asking about rate of change, okay? So when you find the rate of change, that's how you know you can use concave up or down. Like, those two have to go together. Concave up or down is only with rate of change. Okay? Good. Can we look at number 5? Everybody all day has had a question on number 5, so I might as well do it together. Okay? So read it real quick. Let me know what you think. The average rate of change is 1 on that interval. Then the average rate of change is 5 on that interval. What is the average rate of change?
Forgot that show work.
9.
That's what I said.
Okay, how'd you get it?
It's because 1 to 5 is 4 plus 4, then 5 to the minus plus 4.
Now you did it in your head. Perfect. Okay. What? Okay, so here's my little, that's great. Fantastic. But here's like I try, as a teacher, I feel like I have to try and like
Yeah, but on,
visualize
the
it
AP
for you.
On the AP test or whatever, we actually have like show work on that.
No, I doubt it. It would probably just give you like
Multiple
4
choice.
numbers, multiple choice, yeah. Okay, so think about it this way. If you made a table, okay, if you made a table, they're telling me this is the interval, so what does that tell you? Intervals are your x values, right? So you have a -3 and a 0 for this interval. And they didn't give me any numbers, they don't give me any equations, do they? But they're just saying the average rate of change is 1. So I did that just for my because that's how I see it, okay? And then the average rate of change from 0 to 3, so from 0 to 3 is 5.
Oh.
So then the average rate of change from 3 to 6, you kind of are like working backwards, kind of. So you're figuring out that this is a +4, so this would be a +4. So then you're adding 4 to get 9 as your average rate of change. Does that make sense?
Yeah.
Because that second one would match.
Yeah, but you're kind of banking on that, like
The 1 to 5
Yeah.
has to, yeah, totally.
it's like if it doesn't add up to the second
And-
time, then it wouldn't work.
Yes. So we're banking on the fact that it's quadratic and you can do the second difference because sinusoidal curves, you can't do that. And you'll see that, like, sinusoidal. Like here, when you go to do number 12, when you do this and you get 1, 3, 6, 9, when I do the second difference, they don't match. So this isn't linear, it's not quadratic, but it could be, it still can have concavity because it can be something like that, can it? Don't those both have concavity?
Yeah.
Okay. So usually cubic though would all be the same third difference and this one doesn't work. But you're not really looking at this. This doesn't determine concavity. It's really this because it's your rate of change, isn't it? It's your rate of change and is it increasing or decreasing? That's all you're kind of focusing
It's
on.
increasing, so it's going to go up.
Yep. Perfect. Yep. And it says justify your answer.
Because the rate of change is increasing.
Yes. Perfect.